Let's go to the part D for our this B8. It says it's a direct map and size is reduced to 2048 by, you can say it's 2 KB. What is the average number of cycles and average iteration take? Since it did not say how many lines or how big is a cache line, so we will consider that we will have only one line, right? One line with 2 KB. The size is 2 KB. That means we have only one cache line, and it is 2 KB. The size of it is 2 KB, and or 2048 bytes, right? And why it's a 2048 byte? If you remember, we have the table here. Oops, right? We have the table. The table says the A, B, C, D. A will go from 0 to 2047. So how many things inside is 2048? That's totally the same thing. That means if we directly map, when I want to get A0, then I will map the whole A array into our cache line, right? Because they are just have the same size. So when I want to load it, all the array of A we will load into our cache line from A0 to A 511, right? 511. One word is 4 bytes. So we have 512 words. That is what we know before. And also the B, C, and D, right? Blah, 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 blah. And remember, for ABC, I'll read. Just read A, read B, read C, and D, we need to write. We need to change the D, right? Based on the formula. We are doing the execution. D equals to A plus B multiplied by C. Yeah. And that is what the directly map affects us. So let's analyze. So for example, in the first loop 1 or loop 0, okay? So like D0 will want to fetch A0 and B0 and C0. And when I want to read, okay. Initially, our cache line with 2 KB is blank, right? So when we want to read A, we will read from the main memory. We will read the whole A array or the whole line from A0 to A511, right? And how about B? When we want to read B, since we have only one cache line, we have to replace the A. Replace the A with the B to B511. Yeah. So A is a miss, B is also a miss, right? So how about C? C is also, we have only one cache line, so C will replace the B. And then C will get into the line. Yeah. So how about D? We will need to read D and then modify it. So also doing the same thing. Try to read D and no D. We need to replace it. Replace the things inside the cache line. What I'm doing here is just modify the same line because we have only one line, right? Only one line, one cache line. So D will go here. Oops. Yeah. D also have 512 elements, right? So what is the final state? Final state of the line, the cache line, is that we have a cache line, 2 KB, yeah, that's the sign, and we have D0 and 2D511. So no A, no B, no C, right? And since we are doing the the calculation, the D0 is being modified. D0 will be modified. It means it's different from the main memory, right? It's different from the main memory. So if we want to modify or change, you can just say change this line, this cache line. We need a write back. We need to write back the modified data into our main memory. Okay, so I will say I keep my main memory here, and ABCD, right, and my cache line, and my cache. So yeah, when will we need to change the line? When will we need to change the line? Here we will go to the next loop. Previously we are loop 0, and here we are loop 1. Loop 1, we also want to do the D1, want to find A1, B1, and C1. So yeah, we want to read A1. Is it there is a A1? No, because the final state is here. We have the only thing we have in the line is the D0. Remember, it's being modified already until the D511, right? So when we want to get A1, we do not have it. So we want to replace the D data to be the A data. And since it's 2 KB, so we will replace the whole array into our cache line. So the D0 need to be right back. Remember what? If we change the line, the data, we need to write back because we are modifying it. It is different from the main memory, right? It is different from main memory. So we need to firstly, let me say, the action is read A or load A. But firstly, we need to write back the D, from the cache line, to main memory, right? So we will put this line back to the main memory, that is write back. And the second step for the read A will be the read. Will be read from main memory to the cache line, right? Firstly, write back. Secondly, read. So yeah, here we will have one write back. So and until the end, the final state of our cache line is the same, because we are having A and then replace it with B and then replace it with C and then replace it with D. So we will have D0, D1, and blah, 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 go to D511. And this time we will try to modify is the D1. So D1 is 30, or you can say the whole cache line is 30. So if another guy want to change this line, we also need a write back in loop next, loop I plus one, right? So here is the analysis. So how many write back we have? How many write back? You can see from loop 0 there is no write back, right? We can keep it. But from loop 1, start with loop 1, we need a write back. That means if we have 512 loops, we will have 511 write back, right? Actually, you can know what kind of the data have been write back. Let's say go to the final loop 511. Remember, we start with loop 0, right? So from loop 0 to the loop 511, and here is the final loop. the final state of our case line will be the D0, D1, blah, 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 go to the D511. And we are modifying the 511, right? And since we do not have loop 512, so this block is staying here. Just stay and no write back. No write back. The 511 will be stay in the cache line. And it is different from our main memory. Different, right? It is different. Because this D511 is being modified, and this in the main memory, the 511 is from the loop 5. It is from the, actually, it did not change. It just keeping the same thing from loop 0 to loop 510, right? They are the same. They did not change in the main memory. We just change it in the final loop. So yeah, I just want to say we have 512 loops, and there is only the 511 times for write back. So you can see since we are 511 write back, so we can divide it by 512. We can get an average write back penalty, right? Penalty is 100. So this is the average write back for each loop. And remember, since we are being in each loop, we are missing it, and then replace and miss it, and replace and miss it, and D also is a miss it, right? So we have 4 miss, all the write and read are miss. So we have 4 misses. So totally, we will have, firstly, I would say N is the basic with no penalty, right? No miss. And there is 4 multiplied by 100 penalty for read and write the miss. Yeah, and with its penalty, and with the average write back, you can say penalty or cost, right? It is from here, 511 over 512 multiplied by 100. So this is the final step for our question 2 part D. Okay. It's a quite long thing, but the main idea is that we have only one line. If I didn't specify, tell you that how big is each line, we will just have one line, and this line will have the whole size of this cage. Yeah, and you need to analyze this how each loops go. Loop 0, we will want to read and replace and replace and replace. And for loop 1, when we want to load, we need to firstly do the write back thing. Firstly, do the write back things, and then do the read, right? Don't forget the write back. Yeah. And in the final loop, it just keep it in the cage and not write back, since there is no loop 512, right? So no write back. It will keep it. Yeah. So that is for homework 3, question 2, part D. Yeah.